Hello and welcome to today's webinar. My name is Owen Hardwick. I am a Cloud Services Engineer in the vCloud Technical Services team. And today I'm going to be talking to you about vCloud Connector and Datacenter Extension. So let's take a quick look at today's agenda and the topics that we're going to be covering today. First, what is vCloud Connector? Here we'll be looking at the high-level architecture of VCC and some of the options available in terms of workload movement and management. Secondly, we're going to be looking at the configuration and setup. This is where we'll take a brief look at what is involved in getting your vCloud Connector components deployed and configured. The next thing we'll be looking at is copying workloads from your private data center to vCloud Air, and this will also include a demonstration. We're going to be looking at the main ways of moving workloads to vCloud Air. There's three main components and we'll be looking at them all in a little more detail. We will also run through a short demo of a template copy from vCenter to vCloud Air. The fourth topic we're covering today, what is Datacenter Extension? Here I will be explaining what Datacenter Extension is and what is required to get it working. The fifth topic we'll be covering is additional vCloud Connector configuration specifically for Datacenter Extension. Here it's just a brief section highlighting the additional vCloud Connector settings required to start the stretch deploy. And finally, the sixth topic today will just be a demonstration of a virtual machine being stretched to vCloud Air from an on-premise virtual center. Okay, so let's take a look at what is vCloud Connector. One of the biggest challenges of utilizing public and hybrid cloud can be moving workloads from your on-prem to the cloud and vice versa. vCloud Connector is a VMware provided tool for migrating workloads between vSphere clouds and maintaining consistent catalogs. Once you deploy vCloud Connector, you can use it to see, use and copy VMs and templates across private and public cloud environments, tying it all together to create a hybrid cloud environment where customers can combine the best of private and public clouds and have the freedom to move workloads anywhere. With vCloud Connector, with vCloud Air being built on the same trusted vSphere platform as your on-premise data center, workloads, applications, and virtual machines can be moved with minimum of fuss and minimum of configuration. Okay, so let's take a look at the vCloud Connector architecture. An on-premise VCC server plus nodes within each cloud you wish to connect delivers secure hybrid connectivity between private data center and the cloud. So let's look at the three main planes, and firstly the client side. This is the vCloud Connector UI. It's a user interface that the vCloud Connector server produces. It can be surfaced in the vSphere client, and you decide where to display the UI during the configuration process. Next, let's look at the control plane. The vCloud Connector server, the virtual appliance that coordinates the activity of vCloud Connector, controls vCloud Connector nodes, and produces the vCloud Connector UI. Only one vCloud Connector server is needed. Next, let's look at the transport plane, and this will be the vCloud Connector nodes. This is a virtual appliance that handles transferring content from one cloud to another. A vCloud Connector node must be installed in every vSphere or vCloud Director-based cloud that vCloud Connector oversees. vCloud Air has a pre-configured node for all tenants. As today we'll mainly be focusing on the migration and copying of workloads and data center extension, I thought it would be worth noting right now the feature of content sync within vCloud Connector. Content sync allows us to maintain a master library of templates and synchronize these templates across multiple cloud environments. This allows us to ensure consistency of templates across all clouds. You can distribute a virtual machine template or a VApp template across your organization. For example, if a template is added to a folder or catalog that is published to the content library, it will then be added to the user's repository as well at a preset interval. A couple of caveats worth noting with this feature is that there is a maximum number of 10 subscribers per published vSphere folder or VCD catalog. And this does not do delta copies. So that means any change to a template that is sitting in a published folder or catalog means the whole template will then be copied out to all subscribing catalogs and folders. Next, we're going to be looking at the configuration and setup of vCloud Connector, server and node. As the demonstrations I will be doing today will be using vCloud Air, I'm going to be using it in the setup examples also. The setup principle remains the same regardless of what you are connected to though, local, public, vSphere and vCloud. The first step will be to download the latest vCloud Connector server and node OVFs. This can be done through your My VMware account. The next step will be to deploy the OVFs into your virtual center through the standard deploy OVF wizard. The wizard will guide you through the initial configuration and it is important at this stage to assign IP addresses, either static or DHCP, that will be on a routable network. Once both are deployed and configured, it is important at this stage to note the IP address of both the node and the server. This is as the configuration of both is done through a VAMI interface available in a browser running on port 5480. The next step will be to connect our local node to our virtual center. This can be done by browsing to the node's IP on port 5480. Once we reach the management interface, we'll click on the Node tab. Simply enter in the details of the virtual center we wish to connect to. Once complete, we will then browse to the server IP on port 5480 and proceed with adding the nodes to the BCC server. The first node that we will add will be the local node. By clicking on the Register Node tab, we simply enter in the details of the node that is already connected to this virtual center. At this stage, it will now ask you for credentials that are valid on the cloud that we are trying to connect to, in this case, the virtual center. The next step, from the same tab on the BCC server, will be to add our vCloud Air node. The details of this will be sent out to every vCloud Air customer at time of provisioning. It will include the URL and the port to connect on. In this example, you can see, and it's the case with all vCloud Air pre-configured nodes, that is running on port 8443. So this will need to be opened on the corporate firewall to be able to connect to the vCloud Air node. It is also worth noting at this stage, you can see from this example, this is ticked as public during registration. This is very important if you wish to migrate servers back from your vCloud Air instance to the on-prem. On the VCC server, the next step is to register this server as a vCenter plugin. You can do this by clicking on the Server tab and then clicking on the vSphere Client sub-tab. We then enter in the vCenter server IP or FQDN that we wish to use as the UI for this vCloud connector instance. We will also need a username and a password. If there has already been a VCC registered to this, we can overwrite that existing registration with the tick box at the end. Once this is complete, if we then open up a vSphere client to the virtual center that we have just registered to, we will now see the vCloud Connector plugin. From here, we now need to add our source, in this case your virtual center, and destination, in this case vCloud Air, clouds, to the plugin. On the left-hand side of the UI, you will see a clouds icon. Once this is highlighted, we can then add the objects in the right-hand side. When you click this, it will just ask you to select the pre-configured name from the registered nodes that we've configured already and add once more credentials for each of those clouds. It's worth noting again that this is a separate connection going directly from the BCC server to each of the respective clouds for inventory polling only. Next, we will be looking at copying workloads from your on-prem to vCloud Air, migrating our workloads into the cloud. So the first way we can achieve this is through an OVF import over the internet. vCloud Air is compatible with vSphere and customers can do a straight import of an OVF file. This is done using a client integration plugin that will be downloaded through your browser from your vCloud Air instance. This has an embedded OVF tool that's used for OVF and OVA template uploads as well as media files and ISOs. The transfer happens over HTTPS. Bringing our workloads into the cloud is using vCloud Connector. This will be the main tool for customers migrating VMs, apps and templates to and from vCloud Air. It does a HTTPS upload via API for OVF and media. It's integrated into the vSphere client as we've seen earlier and how to configure that. It also includes the features of Datacenter Extension and catalog sync as we discussed earlier. For migrating multiple VMs or templates up to vCloud Air or any other private cloud, it tends to be a lot more scalable than doing OVF imports through a browser. At the moment, we support moving templates of virtual machines of up to 1 terabyte in size and up to 5 migrations running concurrently from any one instance. Blank data transfer, or ODT. This could be used for migrating very large or a large number of VMs, VApps or templates. Storage device that will be shipped to customers by VMware. When it arrives to the customer's data center, they will plug it in. Using VCC, copy the VMs and templates they want down to the storage device and ship it back to their data center of choice. Once it arrives at the data center, VMware operations will then upload to the customer's cloud environment. Looking at ODT in a little more detail, we can see that the service can be activated via the My VMware portal, and this enables the data to be exported from one cloud to another. As mentioned earlier, this is usually used for large amounts of data or large numbers of virtual machines. The data is exported via the VCC UI to the external NAS device that is shipped to you by VMware. The data is then encrypted by vCloud Connector prior to writing to the device to ensure secure transfer. On our side, the data will then be imported by a VCHS operator from the external NAS storage device, and you can see there that the device size is 11 terabytes. Anything over this will require a second device to be shipped out. So let's take a little look at how a VCC transfer happens. Since 2.5, we're using path optimization for all VCC transfer. This has speeded up the process exponentially from the old stage process used prior to this. As mentioned earlier, it's just worth remembering that we now support up to 1 terabyte in VM or template size per transfer. Legacy method. Each part of the transfer happened individually. That means when the VM was exported to your source node, that would need to complete before the next stage would start. So then once your virtual machine has been exported to the local node and it's fully staged there, it would then begin to transfer that to the destination node. Once that copy is completed, it would then import to the destination cloud. It's almost like 3 separate copies. As you can imagine, for larger VMs, this took a huge amount of time, as it was essentially 3 separate copies for the one virtual machine. With the optimized transfer solution, we now export, transfer, and import will all run parallel to each other, fully utilizing the upstream pipe. It amounts to a greatly reduced total copy operation time. At this point, it is worth just looking at some of the known limitations of vCloud Connect. VCC does not support vMotion. All copies are done with powered off VMs or VApps. Our normal suggestion would be for virtual machines that you cannot spare a huge amount of downtime to complete this copy would be to clone that virtual machine and to copy across the clone. VCC doesn't natively support non-VMware based environments like Hyper-V, AWS, Rackspace, Google App Engine, etc. Windows Hyper-V can be converted and then copied afterwards. The VCC offline data transfer, or ODT, will not work in reverse. That means we will not be able to use the ODT process to copy virtual machines from vCloud hybrid service to private vSphere or VCD clouds. And the wizard-based copy does not retain the network configuration inside a VApp. Next, we're going to look at what is data center extension. So what is data center extension? To understand what data center extension is, let's look at a common problem. Our production servers on-prem are all belonging to one network or VLAN, and we want to move some of this workload, temporarily or permanently, to one of our cloud instances. With traditional layer 3 communication over the internet, WAN, VPN, we're talking about layer 3 communication. This means that we cannot have overlapping subnets, meaning when we move workloads across, we need to spend the additional time re-IPing and reconfiguring those virtual machines or application servers. So what data center extension essentially allows us to do is use the same layer 2 network on both sides, that's on-prem and our cloud instance. This allows a greater flexibility when shifting workloads between sites, as it negates the need to re-IP and reconfigure the virtual machines that are being moved. This allows companies to burst to a cloud platform at times of high usage with minimal disruption and time spent. So how is this achieved? It is achieved by means of a secure Layer 2 SSL connection made between an on-prem vShield edge and a vCloud Air vShield edge. If you're already using vShield on-prem and the default gateway for most of your production networks is a vShield edge, then it requires minimal extra configuration, as you already have the vShield edge component on-prem. If not, all vCloud Air customers will be given a vShield manager license, which gives them the ability to deploy an edge gateway into any of these production networks. This does not mean having to change the default gateway of all the production servers. This edge merely needs a leg in that network and an IP address, and also needs an uplink into an external network that has internet access. Once this is configured and used using the vShield APIs, VCC is able to create the infrastructure on the vCloud Air side, that's the VApp, with the VApp network. It also then creates the SSL VPN connection between the vShield Edge on-prem and the vShield Edge vCloud Air. And then, using VCC's migration feature, is able to move that virtual machine over to the vCloud Air side, powered up with the same IP and MAC addresses it had on-prem. Okay, so let's look at some of the common scenarios why you would use a stretched deployed network. As already mentioned, it could be ease of mobility for test dev workloads. There could be application dependencies on MAC addresses, maybe because of a licensing requirement. We could have external application interdependencies, such as hard-coded IP addresses or a lack of DNS usage. Or we could just have existing security rules, switch ACLs, existing firewalls that we want to get around by just stretching that layer 2 network across to our vCloud Air instance. There's usually 2 methods at the moment for vCloud Air to achieve this. One would be the direct connect private line, which through your NSP, setting up something like a VPLS line to the data center. This is usually a fairly costly procedure, The other option then, if you're already an enterprise plus user, would be to use Datacenter Extension, which would be a whole lot cheaper, as it's just using vCloud Connector and vShield, which we provide for you. And this is a VPN-based solution, which we've just been talking about. Again, just let's take a quick look at some of the considerations around using the Streiched network. Streiched virtual machines will always use the on-premise network gateway. It basically means all traffic will traverse the VPN. So if you've got a server deployed, stretched across to vCloud Air, and it needs to get out to the internet, that will still go across the VPN and out your on-prem data center gateway. The next consideration will be Active Directory sites and services. Remember that the Streiched network is part of the on-premise site in Active Directory. DNS and Active Directory calls for vCloud servers will traverse the VPN. You cannot split a network between two sites. And finally, just some of the VApp limitations that are specific to data center extensions, that you can't have more than 128 virtual machines stretched into a single VApp on the vCloud Air side. And the single VApp container contains power operations for all virtual machines within that container. So let's take a look at all the necessary components to get data center extension working. The first is vShield Manager. If you're already not a user of vShield, the license for this will be provided for you by VMware. In this webinar, I have not shown you the configuration of vShield Manager or how to deploy vShield Edge on-prem, but there is a document, if requested, that I can send on to any of you showing the steps to configure the manager and to deploy the vShield Edge for DCE. The next component is a vShield Edge. As just mentioned, from the manager you deploy the vShield Edge. The basic requirement of this edge is to be the endpoint for the SSL VPN on-prem. The requirements for this vShield Edge are just to have an interface sitting in the production network that you would like to stretch, and also an uplink going to an external network that has internet connectivity. The next component is the VCC server node, which I've shown you already. It's a free download from VMware. And the fourth and most important is that we must be using virtual distributed switches. Now we're going to take a quick look at some of the Streiched deploy prerequisites. As you can see from here, the product requirements require 5.1 or higher for vSphere, ESXi, vCloud Director, the vSphere on which the vCloud is based, vShield Manager, and you need a vSphere distributed switch that's 5.1 or higher also. The storage requirements, you will need at least twice the storage in the destination virtual data center of the virtual machine that you are stretching. For instance, if you are stretching a virtual machine with a 40 gig VMDK, you will need at least 80 gigs available in the target vCloud. If the source happens to also be a VCD rather than a vSphere, the same requirement is seen on both sides. This means you'll need to double the storage on both the source and destination virtual data centers. Looking at some of the network requirements for the source vSphere cloud, you can see, as already mentioned, the edge gateway needs to be configured to reach the internet on its uplink. It needs to only be connected to one external network, and the internal interface needs to be connected to a virtual distributed switch. This will not work straight vSwitch. Supported network types for being stretched are a flat vSphere network with the vShield Edge, as already mentioned, configured to reach the internet. Any of the networks that are connected to that vShield Edge that are not flat networks will not be able to be stretched. Now let's take a look at some of the network requirements. If the source is a VCD cloud, the VApp must be deployed in the following way. It must have a rooted VApp network. The VApp network cannot be connected to an isolated organization network. All the VMs in the VApp must be connected to this VApp network. The external network in the vCloud Director cloud must be associated with a port group created in a 5.1 or newer vSphere distributed switch. The IP allocation type in the VApp network must be set to either DHCP or static manual. A static pool IP allocation type is not supported. So just to recap, supported networks on a source VCD cloud is a rooted VApp network connected to a direct org VDC network or rooted org VDC network. Unsupported networks include VMs deployed in a direct VApp, fenced VApp or isolated VApp, or VMs deployed in a rooted VApp that is associated with an isolated org VDC network. To help visualize the supported network types in VCD or VCA, you can see in the following diagram what's supported and what isn't. On the left-hand side, we have a straight VApp network. It's not connected to anything. It terminates at the vShield Edge and is completely isolated. This is not supported. In the middle, we can see, down in the bottom there, we have the VApp network and the VApp network edge. This edge is routed to a rooted org network that has external access. This is a supported network. And on the right, we can see, similarly, another VApp network that is rooted, but the vShield Edge is connected to an isolated org network that has no external connectivity. So this is, again, not supported. Now let's take a look at the Streiched deploy network diagram and how the traffic flows through the SSL VPN tunnel. As you can see here, we have a virtual distributed switch connected to the corporate firewall, which has external access to the public internet. We add in our vShield Edge gateway on-prem. This could actually be the default gateway for the production network we wish to stretch, or it could just be a vShield Edge that's dropped into that same network. You can see it has an uplink to the virtual distributed switch that has external access. You can also see it's connected in to the production network that we wish to stretch. On the vCloud Air side, we can see we have an org edge gateway. This comes as standard with every environment. It's the gateway in and out of the environment. Next, you can see as part of the process, the SSL VPN is established between the on-prem vShield Edge gateway, passes through the edge gateway on the VCA side, and terminates at another edge gateway, which is part of the VApp network, where we are going to be stretching the virtual machine to. You can see on both sides the network is exactly the same. Okay, so the first packet flow we're going to see is traffic destined for a virtual machine that's been stretched over the vCloud Air from the public internet. You can see that the traffic comes in through the corporate firewall, down the edge gateway, across the SSL VPN tunnel, and reaches the virtual machine that has been stretched to the vCloud Air side. The outgoing traffic, or the response, will go back the exact same way it came in, which is across the SSL VPN tunnel and out through the corporate gateway. In the next packet flow, you will see virtual machine on the vCloud Air side that's been stretched from an on-prem data center, communicating back with the virtual machine on-prem. The traffic traverses the SSL VPN tunnel, and the reverse traffic does the exact same. So how does this happen? The first virtual machine on the vCloud Air side is going to send out a broadcast ARP for the IP address of the destination. This broadcast is picked up and using proxy ARP, ferried across the SSL VPN tunnel and broadcast out the other side. The response is unicast, goes back across the SSL VPN tunnel, and now they're able to communicate. For the demonstration, I'm going to quickly just show you the additional vCloud connector configuration settings needed for data center extension. To do this, we'll need to go back to the VAMI management interface on the vCloud connector server. That's the one that runs on the vCloud connector server IP on port 5480. Once open, go back to the Nodes tab and locate the local node and the destination vCloud Air node. If you highlight the cogs under actions for each one, you will see Deploy Stretch Settings. For each one, you will need to click and enable the stretch deploy on both nodes registered to the VCC server. This just involves entering on the on-prem side the vShield Manager URL and a username and password, and for the VCA side, it just means entering the username and password you have for vCloud Air. And finally, I'm going to do a demonstration of a virtual machine being stretched from a production network on-prem over to vCloud Air, and how they have full layer 2 communication afterwards. Okay, so in this short demonstration, we're going to be copying a virtual machine template from our on-prem virtual center to vCloud Air. So you can see here we're going to be using a small gold template. It's just a Linux template that I've created. It's worth noting at this point that the procedure for copying a template or a powered down virtual machine is almost identical. So here's the vCloud Air interface, and here's the link clicking you into the vCloud Director catalog section. We're going to be using the webinar copy catalog to copy this template over in this demonstration. Okay, so let's go to our vCloud connector interface, and we can see here in our on-prem virtual center we have a templates folder, and inside it is a gold template. Highlight the gold template and click on the copy wizard button. So guide us through a wizard where we can set the destination vCloud Air instance as well as the catalog we want to copy that template into. So it's just going to run a quick validation, and then we'll be able to guide ourselves through the wizard. Okay, so the first thing we need to do is select the target cloud. So as you see here, I only have one target or destination cloud configured in my vCloud connector instance, so that leaves the choice just vCloud Air UK. I'm going to leave the name as copy of gold template and select the webinar copy catalog. Again, only one org in this instance, so we select that. It's running another validation, but as you can see in the background, we have a few options: deploy VApp after copy, power on VApp after deployment, and remove temporary VApp template in destination vCloud catalog. If you choose the deploy after copy option now, there's going to be some extra parameters you'll need to configure, such as what network you want to deploy the virtual machine onto in your vCloud Air instance, and so forth. And also the last option means that after it deploys, it removes the temporary catalog item. Okay, so we've skipped past that part. We're not going to deploy, we're just going to copy the template into our catalog ready to be deployed whenever we need. You can see now it's running a final validation. This is actually an end-to-end test. If you're on your virtual center running this, you'll see a task kick off. It exports a validation OVF template just to see that it's got end-to-end connectivity and it's able to write to the destination catalog. A lot of the time this will come back with a warning about latency, but we are going quite a long distance. We're going from Cork over to a data center in London. It's just a warning or a suggestion. You can usually push past it if you wish. So there's the warning. We're just going to finish and begin the copy. Okay, so you can see that copy's kicked off. It will take some time before you actually start seeing that progress bar go up as it runs the first export from the ESXi host to the local node. So we'll flick into the vCloud director. That's the validation template that was copied over just to test the end-to-end connectivity. You can see it there. That will delete itself over time. And what we're going to do at this point is there's no point in watching this really copy the whole template over, so we're going to come back when that's complete and just make sure that everything's in place. Okay, so we can see that the copy of the gold template is completed successfully here on our tasks bar. So what we're going to do is just flick into vCloud director, go down to our webinar copy catalog. From here now you can see that the gold template is there and ready to be deployed whenever it's needed. Okay, so we're going to do a short demonstration on where we're going to stretch one virtual machine from our virtual center on-prem here over to a vCloud Air instance, and we're going to test the connectivity back once that's complete. Okay, before we do that, let's just visualize this on a slide, what exactly we're going to do here. So we've got a production network on our on-prem data center and 4 production servers. You can see them there and their IP addresses, and they're connected to a virtual distributed switch. We've got access out through a corporate firewall to the public internet, and we have a vCloud Air instance with an edge gateway configured there already that gives us access in and out through the internet. We've also got the vShield Edge deployed, and you can see he's got an interface on the internal production network as well as an external network that can get out to the internet, and we have our VCC nodes in place. Okay, so let's just take a look at the virtual center now, and we can see there's our 4 production servers, DC 1 through to 4. Take a look at a couple of their IP addresses just to see that they match up. We've got 10.11, 10.12, 13 and 14. And now let's just test connectivity on all these servers and make sure they can reach their default gateway, which in this case is our edge gateway, and make sure they can communicate with each other. So we're just going to pop open a jump server here that has a PuTTY manager and a connection open to each one of those servers. So you can see DCE 1 through 4 there. Let's just see if DCE 1 can reach its default gateway. And when we check connectivity in a moment between the servers, it's worth noting the latency times. As when we stretch it and we test connectivity back, the latency obviously on the stretch virtual machine is going to increase when it's communicating with the servers left back on-prem. So this is the guy we're going to stretch, DCE 04. He can ping his default gateway. He can ping DCE 1. He can ping DCE 2 and DCE 3. Okay, so let's go back to our vCloud connector user interface. Click here. Click on our virtual center and work our way down to our production servers folder. Click on virtual machines, and let's just see. It's DCE4 we want to stretch. So we can see that that's grayed out, the option to stretch it. If you hover over it, it will give you a clue as to why, it's saying it needs to be stopped. So let's power that guy off. Refresh the UI. Navigate back to the virtual machine, and we can now see that the stretch deploy option is there. Very similar to copying a virtual machine, this will launch a wizard, configure the different parameters. So we've only got one target cloud. We're going to call this guy stretch DCE4. And we need to select a catalog that's just going to stage this guy in during the copy process. So we've just selected webinar stretch. Okay, so again, we only have one org VDC in this demonstration, and we need to connect it to a routable network. So this is the network that the VApp vShield Edge is going to hang off. That vShield is going to be the termination point for the SSL VPN, but obviously it needs to be able to get in and out via the internet, so it needs to be a routable network that I've selected. Once we select that, we get a list of the interfaces, external interfaces configured on our main edge gateway in vCloud Air. We only have one in this instance. And then we'll get a list of the public IPs that are assigned to that interface. So for this demo, I'm going to choose the 110 public IP. And we'll click next. We're not using any proxy to get out, so we don't need to configure it. And we're going to select the power on deployed entity. Okay, so we have everything in place. We'll click finish. And we'll see that the task kicks off. So stretch deploy is done in two separate main tasks. At the moment you just see one that will spawn off a second. The first is it's going to go over and create all the virtual infrastructure on the vCloud Air side that it needs, and the second part will just be copying that virtual machine into that infrastructure, assigning the same IP and MAC address that it had on-prem and powering it up. I'm just showing you, this is the main edge gateway. This is our way in and out of the internet on the vCloud Air side. You can see here, just as mentioned, this is the deploy infrastructure task that it's doing at the moment. So let's flick back to vCloud Director. At some stage it's going to come and it's going to reconfigure this vShield edge here with a DNAT so that it can pass through, and it's also going to create the corresponding firewall rule. So let's go to our MyCloud and search for the VApp that's going to be created. Search for Streiched, we know that's the name, and we can see there Streiched DCE04. Let's click into that guy. We'll see it's still creating and starting it up, but if we click in, we can see it's created the VApp network. That's going to be our 192.168.10.0/24 network, and that little guy that I'm hovering over now, that's the firewall. That's the vShield edge gateway belonging to that VApp. It routes it out onto the internet, and it's also the termination point for that SSL VPN tunnel. Okay, so now it's going to... Okay, so these tasks are going to take some time to complete, so what we're going to do is pop back when these tasks have completed successfully, and we'll have a look on the vCloud Director side at what's been created, and then we'll test the end-to-end connectivity between the server that's been stretched and the ones left on-prem. Okay, so let's take a look in our vCloud Connector UI. We can see that the stretch deploy virtual machine task is completed. Let's just check in the hosts and clusters. Let's check the DC4 powered down, so we no longer have a virtual machine here, but named DC4 powered up. We have 1 to 3. DC4 now should reside on our vCloud Air instance in our London data center. Open up our vCloud Air instance and our vCloud Director, and let's just take a look at what's been created. Okay, so let's just search Streiched again, we know that's what it's called. Find our VApp. Again, we've seen already that being created earlier. We now see it's copied over that virtual machine and powered them up, and DCE4 now resides on our vCloud Air instance in the London data center, connected to a routable network. And if we now go to the administration tab, click down to our main edge gateway. I mentioned it was going to create a couple of rules, a DNAT rule and a firewall rule. We'll take a look at those. So let's take a look at the DNAT rule first. You see it's created on the public IP selected. It's forwarding port 443 down to an internal address there on the routable network, and that's the address assigned to the VApp edge gateway, and we see the corresponding firewall rule. Just take one last look. You can see the VApp network it's assigned to. It's powered on. Okay, so let's have a look at our vShield manager on premise. Just hit refresh there, log back in. We'll just take a quick look at the SSL VPN tunnel that was created by vCloud Connector throughout the stretch process. So I'll click on edges there. I've only got one in this demo environment, so we'll click down on him. Flick over to the VPN tab, and you'll see the SSL VPN that's been created, the local endpoint, local subnets. You see that the peer subnet and local subnet are the exact same. Just give it a minute, wait for the channel status to show as green. Yeah, and we can see that that's been created successfully. Alright, so now let's test connectivity. So I'll open our PuTTY manager. Again, just worth reminding about the latency. Let's take a look. So let's go to DC4. Let's ping our default gateway, which is now in Cork, and we're in London, so it's 10.1. There you see it's full connectivity there. Latency is a bit higher, as to be expected. And let's just check the other virtual machines. So it's DC1. DC2 is the same, and DC3. So the connectivities remain the same. They still all have layer 2 communication between them. Obviously, as I said, latency is just that little bit higher. You can see this guy is pinging locally still. His default gateway exists in the Cork data center, as you can see the latency is a bit lower. That pretty much concludes the demo of a stretch deploy. I hope you've enjoyed it.